There's this invisible force that's constantly shaping your world. It's what picks the fastest route for your morning commute, it's what cues up that next song you can't get out of your head, and it's even what protects your bank account from fraud. And that force, well, it isn't magic, it's an algorithm. And today, we're going to pull back the curtain and see what it's all about.
We hear that word algorithm tossed around all the time, but what is it, really? Well, the answer is way simpler than you might think. And you already use them dozens, maybe even hundreds of times a day. Let's start with a few examples that I bet you'll recognize immediately. So, whenever you pull up a map on your phone, you're not just looking at a static image. Oh no. Behind the scenes, there's a super powerful algorithm that is just crunching numbers. It's looking at live traffic, road closures, speed limits, all to find you the absolute fastest path to get where you're going, right at that very second.
Or how about this? You finish a great series, and your streaming service instantly suggests the perfect thing to watch next. That's not just some lucky guess. It's a recommendation algorithm that's analyzed what you've watched, compared it to millions of other people, and made a pretty darn good prediction about what you're gonna love.
And think about this one. Every single time you swipe your credit card, an algorithm kicks into gear. It instantly analyzes everything about that transaction, the amount, the location, the time, to see if anything looks fishy. It is your invisible, lightning-fast bodyguard against fraud.
So yeah, they're everywhere, from our cars to our couches. But to really get a handle on what they are, let's just forget about all the tech for a minute and look at something way more familiar: our own daily routines.
Think about how you make your coffee in the morning, or how you'd follow a recipe to bake a cake. You might not realize it, but both of those are perfect real-world examples of algorithms. They're just simple, repeatable processes with a clear set of steps designed to get a very specific result.
And that's it. That is the absolute key. An algorithm isn't some complex code or supercomputer. At its heart, it's the logic. It is simply a clear, ordered set of steps you follow to solve a problem. That's the core idea behind literally everything we've talked about so far.
In fact, that recipe analogy is so perfect that we can use it to break down the 3 essential parts of any algorithm, whether you're baking a cake or sorting a billion pieces of data. Every single algorithm, no matter how simple or complex, follows this exact pattern. You start with your input, those are your ingredients. You process them with the algorithm, that's the recipe itself, and you end up with the output, your final delicious dish. Input, process, output. It really is that simple.
And what's so cool is that when you look at the official, formal computer science definition, you'll see it's the exact same idea. An algorithm is just a finite sequence of well-defined instructions that takes an input to produce an output. In other words, it's just a recipe that's so clear, so precise, that a machine can follow it perfectly every single time.
So how does this all translate from the kitchen into a computer? Well, for a computer, the ingredients aren't things like flour and sugar. The ingredients are data.
Let's take one of the most basic tasks in all of computing. Sorting stuff. The input is just a jumbled mess of random numbers. The sorting algorithm is the recipe that tells the computer exactly how to rearrange them. And the output? Well, it's that same set of numbers, but now they're in perfect order. It's the same logic with your email spam filter. The input is this constant flood of new messages coming in. The algorithm acts like a bouncer at a club, analyzing each email against a set of rules. And the output is a really simple decision. Does this go to your main inbox or to the junk folder? But here's the thing. Just like a bad recipe can lead to a total kitchen disaster, not all algorithms are created equal. Some are brilliant and incredibly efficient. Others, well, they can be slow and clumsy. So what exactly separates a good algorithm from a bad one?
A truly great algorithm really has 3 key qualities. It has to be clear, meaning the instructions are totally unambiguous. It must be repeatable, so if you give it the same input, you will always get the same output. And, maybe most importantly, it has to be efficient, solving the problem without wasting precious time or computing power.
And believe me, that efficiency thing is everything. Just imagine 2 different algorithms trying to solve the same problem. A poorly designed one might take minutes or even hours. But a well-designed one, like algorithm A here, can find the solution in a fraction of a second. In the real world, that difference can save companies millions in computing costs and energy.
Okay, so they're basically just recipes that run on data, and efficiency is key. But that brings us to the biggest misconception we need to clear up. This idea that these incredibly powerful tools are somehow a form of magic.
It's really easy to see why people think that.
I mean, when an algorithm can compose beautiful music or defeat a world chess champion, it feels like magic. But here's the truth. Algorithms are not spells. They are tools, carefully designed by humans and then executed by computers with incredible speed and precision. That's it. Nothing more, nothing less.
Even the most advanced, mind-blowing AI you hear about is built on this very foundation. A good way to think of it is like a massive interconnected cookbook with millions and millions of recipes, or algorithms, all working together. The scale is just immense, but the building blocks are still those same simple, step-by-step instructions. And this brings us to a really mind-bending question. We've defined an algorithm as a fixed set of rules, right? But what happens when the recipe can actually change itself? What if an algorithm could look at new data, learn from it, and then rewrite its own instructions? Well, that is the incredible leap from simple algorithms into the fascinating world of machine learning.
So, there you have it. An algorithm isn't magic, it's a recipe. It's a set of human-made instructions that now powers so much of our modern world. And hopefully, the next time you get a perfect movie recommendation, you'll know exactly what's going on behind the screen. Thank you so much for watching.
Here at Knowledge Equity Partners, our whole goal is to share contemporary and practical knowledge on all sorts of topics that can enhance your daily life and make it more effective and efficient.
If you found this content valuable, we'd love for you to subscribe to Knowledge Equity Partners so you'll get notified about our daily videos. And of course, don't forget to like, share, and spread this knowledge with your family, friends, and your community. Let's keep that quest for knowledge going together. And definitely look out for our next episode because we are going to dive deep into that next big question. What really happens when algorithms start to learn all on their own? You won't want to miss that one.